Okay, let's go through these last 3 pages real quickly. On the first one here, we have 8 and x. If you have a diameter that hits a chord at 90 degrees, which this does, then it splits it in 2. So that answer is 8. Number 32, again, it's the same thing. So you have 5x plus 6 has to be equal to 2x plus 9. So subtract 6, you get 5x equals 2x plus 3. So we subtract the 2x to the left, and you get 3x equals 3. So x must be 1. Now to find the arc, we have to do a few things here, set up a proportion. So the arc, RS, is to the, oh, I'm sorry, that's not the distance here. It just wants the degree. So if it were at the center, remember, the arc and the central angle are the same. But it's not, it's back here. So what you have to do is you double this angle. If you look at 67 degrees and you also look at this degree, the 67 is smaller than this part right here. Okay, so we have to double it to match this one. So this is 134 degrees. Okay, think about this for a second, just so you can use your wisdom. Here's a straight line which is 180 degrees. So RS is not 180 degrees, but it's definitely not less than 90. So that should help you understand that your answer is 134 degrees. But you double those. Now to find x and y, anytime you have a quadrilateral that's inside of a circle, that's the key point. These are supplementary to each other, and these are supplementary to each other. So x and 80 have to equal 180 degrees. So that means x is 100, and 180 minus 95 will give me y. 180 minus 95 is 85. Now, we have a formula down here. We have a crisscross, which means we're going to add, remember these formulas. You get these formulas in that sheet. This is 1/2 the big arc plus the small arc. So the big arc and the small arc, 145 and 85, is 230 degrees. And then we take half of that. So 1/2 of 230 degrees is 165 degrees. So you already have the answers to these that I sent you earlier. So we're just showing you how to come up with them. Again, we have a crisscross here, except this is the distance of your arcs. All right, so on 35, the first 35, you have degrees, and the second 35, you have the length of the arcs. And the formula for that, those two formulas are together on that formula sheet. So here you do 12 times x, and that equals the 10 times 6. So x must be 5. Okay, finally on number 36 here. Again, we have the length of the secant here. And you take the outside times the whole. Remember, that's how you do this. So the outside is 5 times the whole thing, which is 12. That is equal to the outside x times the whole thing. How'd you get 12? 5 plus 7. How do we get this one? X plus 4. Okay, so I'm going to move this over to the right here. So we have 60 equals, and we distribute the x, we get x squared plus 4x. And this is going to make excuse me, it's going to make a trinomial. I'm going to rewrite it here. X squared plus 4x minus 60. That's kind of hard to see too. Let's change that to blue here. And this trinomial factors in from 60 to give us positive 4. We need 10 and 6. So x plus 10 and x minus 6 will give me positive 4. And positive 10 plus, times negative 60 gives me negative 60. So it equals 0, so either x is negative 10 or positive 6. Well, in this situation, x is a distance, so it can't be negative. 6 is the answer. 37. Again, you take the outside, x, times the whole thing, x, and the other side, 7 is the outside, times the whole thing, which is 16. So x squared equals 7 times 16 on your calculator, and you get 112. And we just take the square root of 112. Remember, I want to see you break this down. So that's 2 and 56. 56 breaks down into 2 and 28. And you just kind of keep going. And 28 is 4 and 7. So here we have a double. That's 2 without the radical. The square root of 4 is 2. And we have a square root of 7. So this would be 4 square root of 7. And you could use your calculator at this point. You could just take the square root of 112 on your calculator. If you wanted to know what that was as a number, 10.6. Okay. Now we're on number 38. Give the equation of a circle. So you look at 4 and 1, and remember we use the opposite numbers, so this is going to be x minus 4 squared plus y minus 1 squared equals 25. And go to the next one. So if we want the center from these, we use the opposite numbers. So the center is at negative 5 and positive 3. And then to get the radius, you have to take the square root. Okay, so that's how you do that page. Let's go to the next page. Okay, number 40, find the arc length. So arc length, excuse me, arc length is to the circumference, which is 2 times pi times r, as the degree is to 360. So if you want to write it on your formula sheet like this versus what it is on the formula sheet, that's okay. We don't know the arc length, that's what we're finding. The radius is 6, and the degree is 80. So now we just do, on your calculator, we take 2 times pi times 6, and times 80, because we're going to cross multiply here, times 80. And then we'll divide by 360, excuse me. And that gives us our answer of 8.4. It should be a decimal there. 8.4. Find the circumference. Circumference is 2 pi r. So 2 times pi, and the radius is 4. So 2 times 4 times pi on your calculator is 25.1. We're not doing density, population density. Area of the shaded sector. So the area of the shaded sector of the sector is to the whole area. Area of a circle is pi r squared, as the degree is to 360. Again, you can change the 1 on your formula sheet to this one. Area of the sector, we don't know. That's what we're trying to find. The radius is 6, so we're going to square that, and the degree is 70. So again, let's do pi times 6 squared, so 36 times pi is 113.1 times, we're going to multiply it by 70, and then we're going to divide by 360. And we get 21.99, so we'll just say 22. 22 is okay. And that, since it's area, it's square units. We don't have any units on here, so we'll just use the word units. Okay? Now, the area of a kite is 1/2 times your diameters. So that's on your formula sheet as well. Our diameters are 6 and 12. You add those together. So 6 times 12 is 72. Half of 72 is 36. And again, square units. Find the central angle of a hexagon. So number 45. Central angle, you have a hexagon. You have 6-sided figure. Okay, so what it wants is, if you have a circle that's 360 degrees, well, what is the central angle? Okay, well, there are 6 triangles we can put in there. 6 sides. You always take 360 divided by however many sides you have. okay? And that's going to be 60. So that's your central angle of a hexagon. Finding the apothem on a six-sided figure. Again, this area right here is 60 degrees. So this little area must be 30. And the whole side is 8, so this is 4 on half of that base. So the area of the big triangle here, let me use blue here. The big triangle is 1/2 base times height, except it's asking just for the apothem. We don't need to find the area. So to get the apothem, we use trig, SOHCAHTOA. SOHCAHTOA. Now, which one of these do we use? Well, from the 30-degree angle, we have the opposite leg and the adjacent leg, which is tangent. So we're going to use the tangent of 30 equals the opposite leg 4 over the adjacent leg, the apothem. So we're going to multiply by a on both sides, and then we'll divide by the tangent of 30. And use your calculator. So 4 divided by the tangent of 30 is 6.93. Okay, volume, it's a box, so length times width times height. Length times width is the area of your base. Your base is right there, so that's 40. And then times 3 is 120. And it's volume, so it's cubes. How many cubes will fill that? Down here, the area of your base is a triangle, so that's 1/2 base times height times the height of the prism. So your base is 7, your height is 10, and the height of the prism is 5. 7 times 10 times 5, 7 times 10 times 5 on a calculator divided by 2. And you get 175 cubic units. And you have a cylinder here, so the volume, the area of the base of a cylinder is a circle, so that's pi r squared times the height of the cylinder. So the radius is 3, the height is 10. 9 times 10 is 90. 90 times pi on your calculator is 282.7 cubic units. And let's look at the last page. Okay, real quickly, let's go ahead and mark out the things we don't need to know here. We don't need to do 59, and we don't need to do 60. All right, so let's go ahead and get started on the rest of this. Volume, again, we'll continue with that. So we have a volume of a pyramid here. So we have the volume of a pyramid here, so we need to remember that you're taking 1/3 of the volume of a prism. So the area of the base times the height. The base is a rectangle, so that's length times width, and then the height of the pyramid is 7. So we have 12 and 16 for your length and width. Take your calculator and take 12 times 16 times 7, and then divide by 3. And you get 448 cubic units. Number 51, it tells you the volume. And the volume equals the area of the base. The base is a triangle, which is 1/2 base times height. The base is 11, the height is 9, times the height of the figure. So we're trying to find the height at this point. So we need to figure out what 1/2 times 11 times 99, 11 times 9, so 99 divided by 2 is 49.5. So we have 198 equals 49.5 times h. So we need to divide off the 49.5. So 198 divided by 49.5 is 4. Our height is 4 yards. It gave us the units this time, so 4 yards. All right, number 52. The pyramids are similar, so we do volume is to volume, so 256 is to x, so 256 is to x. As the scale factor, 12 is to 3, and then we cube that. So we have 256 is to x, as 12 over 3 is 4. 4 cubed is 64. And cross multiply. Okay, so we're going to take x times 64, and 1 times 256, and divide by 64. And we'll get 4. So 4 feet, cubic feet, is the volume of that little pyramid. Okay? Surface area. The surface area of a cone is the area of the base, which is pi r squared, the circle, plus pi r l. L is the slant. The radius is 8, and the slant is 16. So do these separately. So 8 squared is 64. 64 times pi is 201.1. And 8 times 16 times pi is going to be 402.1. Add those together, we get 603.2 square units. The volume 154, again, it comes to a point, so we got to take 1/3. So 1/3 of the area of the base, which is pi r squared. Pi r squared is the area of a circle, times the height of the cone, 13. So we have 1/3 times pi times 10 squared times 13. So we got to do the exponent first. So 10 squared is 100 times 13 is 1300 times pi. And then at the very end, we divide by 3. So 1,361.4 cubic units. Surface area of a sphere is 4 pi r squared. 4 circle areas. Pi r squared is the area of a circle. You got 4 of them. So 4 times pi times the radius, which is 4 squared. So 4 squared is 16. 16 times 4 is 64. 64 times pi is going to give you 201.1 square units. The volume of a sphere is 4 times pi times r cubed all over 3. So our radius is 6, so 6 cubed on your calculator, or 6 times 6 times 6 is 216, times 4 is 864, times pi. And at the very end, don't forget, divide by 3. So 904.8 cubic units. And the last part is all about probability. So let's just quickly go over that. On a number cube, a dice, okay, you roll one of them, the probability of rolling a 2 is 1 out of 6. Done. If you flip a coin and then roll a die, is this are they independent of each other, or does one depend on the other? Well, if you flip a coin, that has no bearing on what you're going to get when you roll the die, and vice versa for that matter. So these are, independent from each other. Okay, so an example of something that's dependent. If I have a deck of cards and I want to know the probability of drawing a heart, and then a spade, the question is, am I putting the first card back? If I put it back in the deck, then it has that drawing that heart has no bearing on the second one. But if I don't put it back, the probability of drawing a heart is 13 out of 52 cards. There's 13 hearts. And, meaning multiplication, the probability of drawing a spade. Now this depends. If I put it back, then there's still going to be 13 out of 52 cards. But if I don't put it back, then it's going to be a possibility of 13 out of 51. You are to assume that you actually drew a heart, what you wanted to, on the first draw. So notice at the bottom, it's out of 51 because we didn't put it back. In that case, it's dependent. But if we put the card back, then there's still 52 cards to draw from, and that becomes independent at that point. All right, so probability of an even on a number cube, there are 3 evens, 2, 4, and 6, so that's 3 out of 6, or means plus, and then the probability of prime. So let's look at this for a second. Even is 2, 4, and 6. Prime numbers on a number cube are 2, 3, and 5. The problem with this one, you want to say the answer at this point, there are 3 prime numbers, so 3 out of 6, and that's correct at the moment. If you stop there, here's what you're saying. The probability of rolling an even or a prime is going to be 6 out of 6. If you add 3, 6, and 3, 6. That means 1. You have a 100% probability of rolling a 2, 3, 4, 5, or 6. Well, what about the number 1? Are you telling me there's no probability of that? So the problem with this is we have two numbers that are overlapping. So you have to subtract out the probability of rolling one of those. So when you do this, you will get 5 out of 6. Okay, which makes sense. 2, 3, 4, 5, 6. There's 5 of them out of 6 possibilities. All right, let's do and here. The probability of an even, rolling an even, is 3 out of 6. And means multiplication. And then prime, you have 3 of those. Now these are independent events. You roll the die, and then you pick it back up and you roll it again. You still have the same amount of possibilities on the second roll. So they are independent of each other. It's not possible that you're going to you could duplicate something, but you don't need to take it out. Okay? You're not saying or. All right? So the probability of this is 9 out of 36, or 1/4, or 0.25, or you could write it as 25%. So very different possibilities there, and that is the practice exam. Good luck on your exams this week, guys. I'll see you tomorrow.